Hello everyone, I am Dr. Jyoti Thakre. Today we will continue with the same unit, that is water technology. First we'll see what are the requirements of the drinking water, because today we are studying the domestic water treatment. So first we'll see what are the requirements of the drinking water. There are some requirements of the drinking water. Its pH should be around 7.5 to 8.5. That means our water that we are drinking should be slightly alkaline in nature. Its hardness should be around 150 to 250 ppm as CaCO3 equivalent. That means it should not be very soft and it should not be very hard. It should be free from any disease producing microorganisms, because this disease producing microorganisms in water lead to very many waterborne diseases like cholera, typhoid, jaundice, etc. The water that we are drinking, it should be clear, colorless and should have good taste. It should not contain any poisonous or objectionable matter. It should be odorless. Dissolved oxygen should be around 4 to 5 mg per liter. Dissolved solids, total dissolved solids should not exceed 500 mg per liter. Its turbidity should not exceed 10 ppm. It should be free from dissolved gases like H2S, because these dissolved gases gives pungent smell to the water. So these are some of the basic requirements of the drinking water. Now treatment is given to water to satisfy all the requirements that we have seen on the earlier slide. During the treatment, suspended colloidal particles and disease causing microorganisms are destroyed. The treatment involves stages. The first stage is the sedimentation, second is coagulation, third is filtration, followed by sterilization. So in this video, today we'll be doing these three stages: sedimentation, coagulation and filtration. So one by one we'll see. Sedimentation. What is sedimentation? It is the process of removing suspended impurities by allowing the water to stay undisturbed for some time in large tanks when most of the suspended particles settle down due to force of gravity. Now next is coagulation. It is the process of removing colloidal particles from the water by addition of certain chemicals known as coagulant. Examples of coagulants are alum, ferrous sulfate and sodium aluminate. These coagulants react with water and forms bulky gelatinous precipitate known as floc. As this floc descend through water, they absorb or catch fine particles from water and forming bigger flocs, which settle down quickly by sedimentation. The addition of coagulant to water also removes color, odor and it also improves the taste of the water. Now we'll see one by one the reaction of this coagulant with the water. Alum. This is the most widely used coagulant in water treatment plants. Alum reacts with water in presence of alkalinity, or this alum also react with calcium bicarbonate. But we'll see what is the reaction of alum with the water. I've told you that this coagulant reacts with the water to form the floc. This is your aluminum hydroxide. This reacts with the water to form this particular floc. You see the acid is formed, and because when we use this alum as a coagulant, it makes the water acidic in nature. For best result, the pH of water should be around in the range of 6.5 to 8.5. The next coagulant is sodium aluminate. It is used for treating water having alkalinity less than 7, because for best result the pH is 5.5 to 7. Because from this reaction only we can see that when sodium aluminate is used as a coagulant, it reacts with the water to form this floc and the water becomes alkaline in nature by formation of NaOH. So this sodium aluminate treatment is given to the water which is acidic in nature. The last coagulant is ferrous sulfate. It gives best results with the water having pH above 8.5. This also reacts with the water to form FeOH3, which is again a floc. So these are the general three coagulants used for coagulation. So depending upon the initial pH of the water, this proper coagulant is used. The next process said followed by coagulation is filtration. Filtration is the process of removing insoluble colloidal and bacterial impurities by passing water through a bed of proper size material. By filtration, suspended matter, insoluble colloidal matter, most of bacteria's colors and odor of water is removed. Two types of filters are commonly used, that are gravity sand filter and pressure filter. So one by one we'll see both the filters. In gravity sand filter, it consists of large shallow rectangular tank made up of concrete. At the bottom of the tank there is a channel of bricks through which filter water goes out. Over this channel there is a layer of coarse and fine gravels about 30 centimeter thick. You can see here this 30 centimeter thick. They are placed above the channels. Sedimented water enters the sand filter from the top. As the water percolates through the sand bed, fine suspended particle, most of germs and bacteria are retained by the top sand layer. Here the top sand layer. This is the top sand layer. Clean filter water is collected in these channels through this channel from which it is drawn out. The rate of filtration after 24 hours of use becomes slow due to clogging of pores. On the top sand layer by impurities retained in the pores. Therefore, the portion of top fine sand layer is scraped off and replaced by a new sand layer. The filter is put to use again. These filters are best used for municipal water supply. The next type of filter is pressure filter. Pressure filter consists of cylindrical vertical steel tank containing 3 layers of filters media one above the other. They are pebbles, coarse sand and fine sand. Impure sedimented water is mixed with small amount of alum solution. It is then forced under pressure from top of the tank. Added alum forms an artificial slimy layer on the filtered bed, and this helps in removal of colloidal and biological impurities. The function of the deflector plates provided at the top is to distribute the slimy layer uniformly over the top of the filter bed. Filter water, as it comes out from the bottom of filter, is under pressure and thus be pumped out. Pressure filters get clogged after its use for some time and its periodical cleaning is necessary. So these are the two types of filters which are being used. But pressure filters are economically only for small scale water supplies such as municipal water supplies. So now we have seen 3 processes: sedimentation, coagulation and filtration. This filtration is now followed by sterilization, which we'll see in the next slide. So these are the basic treatments that are given to the water which should satisfy all the requirements that is needed for drinking purpose. You can see here this is the complete cycle of water treatment. It starts with first sedimentation, coagulation, filtration, and then there is disinfection. Disinfection process is also called as the sterilization process. This disinfection can be done by using UV rays, ozonization or chlorination. Some of these methods can be used. So in next video we'll see the different processes of disinfection. So today we have studied what are the different steps that are being used for domestic water treatment. So this is simple a schematic diagram for the domestic water treatment step. Coagulation, flocculation is always followed by sedimentation. Actually we start with sedimentation because most of the suspended particles are removed. But coagulation is always followed by sedimentation. Filtration, today we have seen there are 2 types of filter: gravity sand filter and vertical pressure filter. followed by sterilization, where different methods are being used for sterilization. So in next video, we'll continue with the sterilization processes, different sterilization processes that can be used for making the water useful for drinking purpose. Thank you.